A projectile is launched with a speed of 40 meters per second at an angle of 60 degrees above the horizontal. Use conservation of energy to find the maximum height reached by the projectile during its flight. Okay, first we should draw a diagram, and we are asked to find the maximum height of the projectile during its flight, and the equations that should be used are the gravitational potential energy formula and the kinetic energy formula. And we can see that at the start the projectile has no gravitational potential energy because the height is 0, so it only has kinetic energy. And when the projectile is at its peak, it has both kinetic and gravitational potential energy, which is shown here. And we know that the initial velocity, 40 meters per second, we know that the initial velocity is 40 meters per second, but we don't know the final velocity at the top. And we can solve for it because at any point it only has, because at this point it only has horizontal velocity, and when an object is thrown horizontally it doesn't accelerate. And so the final velocity turns out to be 20 meters per second. And now all we have to do is plug in the variables. So right here, the masses all cancel out, and then we plug in initial velocity, which is 40 meters per second, gravity, which is 9.8 meters per second squared, and the final velocity, which is 20 meters per second. And the final answer is 61.2 meters.